Hey Annie, I figured out how to do this problem number 9. Actually, I had known about L'Hopital's rule, but I thought I had a more algebraic way instead of using calculus to do it. Let's see what's happening here. Sorry about that mess up there. Okay, so this is L'Hopital's rule, and it looks horrible, but it's really pretty easy. And you apply it when you have an indeterminate form. And all that means is, let me just write this, find the limit as x approaches -1 of this function right here. And it's indeterminate, meaning we can't determine it because it's divided. If I replace x with -1, then we're dividing by 0, which we already talked about that you can't do. Okay, so what L'Hopital's rule says is that the limit as x approaches some constant, and in our case the constant is -1, of a function divided by another function. So in our problem, this is our f of x, and this is our g of x right here, is equivalent to the limit as x approaches the same constant of the derivatives of those two functions. You just take the derivative of each, and then you can do direct substitution, and that's going to work out swimmingly for us. Now, this is going to involve the chain rule and power rule, which I guess he's introduced to you. And I'll provide, we can go over them more in our next session, but I'm going to be using those rules. So if you don't understand those rules just yet, it's okay, because we'll explain them, but it's a very simple method as to how to find this derivative. Okay, so I'm going to say from here that this is equal to the limit as x approaches -1 of, and I'm going to rewrite the square root of x squared plus 8 as x squared plus 8 raised to the 1/2 power, because the square root of, any like z is the same thing as z to the 1/2 power. Whatever's under the square root, in this case x squared plus 8, we raise to the 1/2 power, minus 3 over x plus 1. Okay, well that's going to be equal to the limit as x approaches -1 of the derivatives of these. So I'm going to refer to this top one here as f of x, okay, and the bottom one here as g of x as I do my scrap work over here. So if f of x equals x squared plus 8 to the 1/2 power minus 3, then the derivative is equal to, and what I have is two different terms, and luckily I can find the derivative by taking the derivative of each of them individually. And the first term is x squared plus 8 to the 1/2 power. So we have two different functions going on here. We have the square root, and then under the square root we have another function, x squared plus 8. And the chain rule says I have to take the derivative of the outside and multiply that by the derivative of the inside. Okay? So the outside function is the square root or the 1/2 power. So to take that derivative, I'm using the power rule, which means 1/2 out in front of this times x squared plus 8 to the 1/2 minus 1 is -1/2. Okay? Then I multiply that by the derivative of the inside function. And the derivative of the inside function, x squared plus 8, is 2x. Okay, because the derivative of x squared is 2x, and the derivative of any constant is 0, or any number. Okay, and so then going along with that, the derivative of minus 3 is 0. So I'm done with the derivative of f prime of x. I am going to rewrite that because I am going to have to evaluate this thing. I'm going to have to replace it with x with -1. So I'm going to rewrite this as 2x over 2 times the square root of x squared plus 8. Okay. This 2 comes from the 2 down in the denominator here. The square root goes down in the denominator because of the negative exponent, right? So I kind of skipped a step there. I could have written this as x squared plus 8 to the 1/2 power, but I knew I'm going to have to put it into the square root to evaluate it, so I just went ahead and rewrote it. Okay. G of x is equal to x plus 1. The derivative of this is much, much easier because this is really x to the first power, right? So I bring the 1 in front, so that's equal to 1 times x to the 1 minus 1, and 1 minus 1 is 0, so that's 1 times x to the 0 power. And remember, anything to the 0 power, besides 0, is equal to 1. So x to the 0 power is equal to 1, so 1 times 1 is equal to 1. So the derivative of g is equal to 1. So now things are working out swimmingly because I'm going to use L'Hopital's rule and take the limit of, as x approaches -1 in this case, of the derivative of f of x, which is 2x over 2 times the square root of x squared plus 8, divided by the derivative of the function in the denominator, x plus 1, which we found to be equal to 1, okay? But anything divided by 1 is equal to 1, so I'm not even bothering, I'm sorry, is equal to the anything, right? So I don't need to divide by 1, I don't need that part of it, so all I have to do now is use this, okay? So now I can use direct substitution because I do not get something undefined. So this becomes 2 times -1 over 2 times the square root of -1 squared plus 8, which is equal to 2 times -1 is -2 over 2 times the square root of -1 squared is 1 and 1 plus 8 is 9, which becomes -2 over square root of 9 is 3, and 2 times 3 is 6, which simplifies to -1/3. And so that's the answer. The limit as x approaches -1 of x squared plus 8 minus 3 over x plus 1 is indeed equal to -1/3. Okay, that's it. Hope you enjoyed it, and we can talk about it next time we meet if we need to.